What's up, Algebra 2 students? This is Lesson 39. Our objective for today is how do you factor difference of squares and what are the properties of a rhombus? Alright, so I want you to expand these. Yes, I said you. So, stop the video. If you do not know how to expand these, I'm going to work one out. But I want you to expand these and then play the video again and check to make sure you got these right. And then we want to draw a conclusion based on what we just found. So pause the video right now, expand these out on your own piece of paper. Ready, go. Alright, in case you totally forgot how to do this, we just want to FOIL these. So I'm going to say first, x times x is x squared, outer. X times negative 2 is going to give me negative 2x, inner. 2 times x is going to be plus 2x, and last, 2 times negative 2 is going to give me negative 4. Combine like terms, which are those ones in the middle, negative 2x plus 2x happens to give me 0, so it's going to give me x squared minus 4. Okay, now, you know how to do that, so pause the video and do the other three. Okay, welcome back. So notice these. If you notice on all of these, the middle term reduced to 0. Some might say they canceled out, but they reduced to 0. And notice also the first term and the last term happen to all be perfect squares. X squared is a perfect square, 4 is a perfect square. X squared 81, 4x squared is a perfect square, 1, 9x squared, and 9. Those are all perfect squares. And notice all of them are subtracting. So we call these difference of squares. So if we want to draw a conclusion, this is going to come out to be ax squared minus b squared. Okay, so you kind of saw this. You could look and say, hey look, this is going to be x squared minus 9 squared, which would be x squared minus 81. So that would follow this pattern right here. And because of this, we can actually start from here and go this way. So if we have something like this, the difference of squares, we can factor it to something like this, and that's actually what we're working with today. So it says solve this. This one actually has a couple different ways to solve it, but we'll solve it kind of like the book would do it. So we need to factor this to say something like this. Notice these are both perfect squares. So I'm going to have 2x and 2x. One's going to be plus, one's going to be minus. 4 and 4. This is equal to 0. Since something times something equals 0, that means each of those, one of those somethings must be 0. So I'm going to say 2x plus 4 is equal to 0. Or 2x minus 4 is equal to 0. Solving each of those individually, if I subtract 4 here, I have 2x is equal to negative 4, which means x is going to equal to, when I divide by 2, negative 2. Or, if I add 4, 2x is equal to 4, divide by 2, x is equal to 2. So my answer is going to be negative 2 and 2. Okay. There's another way to do that, and if you figure that out a different way, great. If not, that's okay. So let's do this next one here. Same idea, these are perfect squares. That is 100x squared, and that's a 9. So this is going to factor to 10x and 10x plus 3 and minus 3. So we're just kind of looking for the square root of each of those, and that's what we're going to plug in. One with a plus, one with a minus. So that means 10x plus 3 could equal 0, or 10x minus 3 is going to equal to 0. One of those must equal 0. Solving both of those, go through this semi quickly. Subtract 3 divided by 10, x equal to negative 3/10. Add 3 divided by 10, x can equal to 3/10. So then my answers would be negative 3/10 or 3/10. That's a basic idea. Alright, these are properties of a rhombus. I say a rhombus, so I remember to put that H in there whenever I'm spelling it, but it's a rhombus. And a rhombus is a parallelogram that has 4 congruent sides. So it has all the properties of a parallelogram, meaning that the opposite sides are parallel to each other. So that one would be parallel to that one. That one would be parallel to that one. Opposite angles are congruent, so this angle would be congruent to that angle. And consecutive angles are supplementary. So if this is A, B, C, D, this one means that angle A plus, I guess, the measure of angle B is going to equal to 180. Remember, supplementary means they add up to 180. So any two angles right next to each other would add up to 180. And then a few more properties. It says all the sides are congruent by definition. Alright, we said it's a parallelogram where all 4 sides are the same. Diagonals bisect angles. So the diagonal from A to C is going to cut this angle. So this angle right here is going to be the same as this angle right here, which would also be the same as this angle right here, and the same as that angle right there. Because angle A is congruent to angle C, and they're cut. So that's cool. And same idea here with this one from B to D. This angle would be the same as this angle, which would be the same as this angle, which would be the same as this angle. Okay? And then diagonals are perpendicular bisectors of each other. So that means that these meet at a right angle, and that this side length, if I call this point E, EC is going to be the same thing as AC. That one's the same as that. Same as that. And then this side length is going to be the same as that side length. BE is going to be the same thing as ED. They bisect it. Okay? So let's use the properties that we have to do example 39.3 and see what we can figure out. First of all, it says this is a rhombus. The measure of the reflex angle is 280 degrees. So we're looking for A, X, B, K, and C. So this angle out here is 280 degrees. Well, I know a full circle going all the way around, that would be 360. So I know this angle right here would be 360 minus 280, which is going to give me 80 degrees. So I know X plus A is going to equal to 80 degrees. And since I know X and A are going to equal to each other, that means each of those would be 40. So I'm going to say A is equal to X, which is equal to 40 degrees. So that's 2 of my answers. It's that one and that one. Okay. Let's go to a different color here slightly. We're looking for B, K, C, and F. Sorry, B, K, and C at this point. Well, I know this angle and this angle would add up to 180 degrees because those are supplementary. So, and I also know that this angle right here, this first one, is 80, right? No, we just said this one's 80. So I know K plus B plus 80 is going to equal to 180. So that means K plus B is going to equal to 100. And then, of course, K and B are the same because the diagonals bisect the angles. So then K and B would both be 50. So then K is equal to B, which is equal to 50. Okay, and then to find the measure of angle C. Actually, C is probably the easiest one to find because of that word right there. the diagonals are perpendicular bisectors of each other. So that means this line here and this line here are perpendicular, which means they meet at a 90-degree angle, which means all 4 angles there are 90. So the last thing I'm looking for is C is equal to 90. And there are my 5 pieces. The homework is there awkwardly on the right-hand side of the screen, so flip your computer over so you can read that. You're going to do the practice part. It's actually right before the lessons, the lesson homework there. You're going to do all 3 of those, A, B, and C. You're going to do 7 through 12 all, and then 6 more of your choice. Good luck.